If you own a Volkswagen Transporter, Caravela, Multivan or California Model T5 produced from 2009 to 2015 with a 2.0 BiTDI engine with 180 horsepower, then your vehicle has a serious defect. The engines of these cars, after driving about 100,000 kilometers, can already burn even a liter of oil per every 1,000 kilometers. Additionally, they develop problems with low oil pressure, and if we ignore them, it leads to engine seizure. Why does this happen? What is the cause? How can it be fixed? This film is about that. Well, the main cause of such rapid wear of the CFCA engine is tiny bits of aluminum that get into the combustion chambers of the engine, that is, into the cylinders. These aluminum fragments, due to the pressure in the cylinders during engine operation, are pressed between the piston and the cylinder, where they act like sandpaper. They damage the cylinder walls and pistons. Then, getting into the oil, they are carried with it to all the lubricated parts of the engine, causing their gradual seizing. Exactly as if we added sand to engine oil. Here you can see vertical scratches on the cylinder walls. Because of these scratches, the oil, instead of being properly scraped, is burned. As a result, ash is produced, which additionally causes the rings in the pistons to stick. Stuck rings almost do not scrape the oil at all, so its consumption increases. Where do these pieces of aluminum in the cylinders come from? We explain in the next part of the film. The only way to fix this problem is to perform a rather costly major engine overhaul, during which, in addition to replacing the damaged pistons, the engine block and head, as well as the crankshaft, need to be reconditioned, and many other components need to be replaced. Authorized Volkswagen service centers do not offer repairs for CFC engines, only replacement of the unit with a new one. According to the service manual, they also replace the DPF, catalytic converter, lambda sensor, and many other components along with the engine. The cost of such a repair at an authorized service center, according to the preliminary estimate, is about 70,000 zlotys. By choosing to perform a complete overhaul of the CFCA engine at our service, you will spend only a fraction of that amount. Due to the varying degree of engine component wear and the condition of engine accessories, the final estimate for the engine repair is only possible after it is removed from the car, disassembled, and the condition of its parts is examined, as well as testing the accessories. So, step by step. Of course, to perform a complete engine overhaul, it must be removed from the car. The next step is to verify the condition of the engine's auxiliary components, whose efficiency directly affects the unit's operation. Components such as turbochargers, there are two in this engine. If they are seized, which unfortunately happens very often, must be regenerated. We also check the condition of the injectors and fuel pump on special test benches. This is very important because faulty injectors could destroy the overhauled engine. New Bosch injectors for this engine cost about 8,000 zlotys. Therefore, assessing the condition of your injectors is crucial when deciding whether to overhaul or replace the engine. If your injectors turn out to be faulty, then the engine overhaul may no longer be cost-effective, because after adding the cost of the injectors, the total amount for the entire operation will approach the price of a new engine, which comes with injectors included. Now we are disassembling the engine into parts. We wash all the components and assess their condition, sorting them into those suitable for reuse, those that can be regenerated, and those that must be replaced. We check the condition of the crankshaft. In most engines of this type, the wear on the crankshaft is significant enough to require grinding and the use of oversized bearings. We are checking the engine block. In all CFC engines, the cylinder wear in the engine block is so significant that it is necessary to bore for oversized pistons by 25 hundredths or even 50 hundredths of a millimeter, and sometimes it is necessary to insert new cylinder liners. In engines that were seized, it is also necessary to align the crankshaft bed in the block. We check the head's tightness in every engine we repair. Sometimes the head turns out to be cracked. In such a case, it needs to be replaced. We check the condition of the camshaft bearings. If the wear is excessive, it is necessary to align the head, and in extreme cases, the head must be replaced. We check the condition of the valves removed from the engine head. The valves are also very often so worn that they need to be replaced. Only after performing these actions do we know which parts in this specific engine need to be replaced, which elements need to be machined, and which can potentially remain old. Of course, the elements that need to be replaced in every engine of this type are pistons, all crankshaft bearings, guides and valve seals, gaskets and seals, and many bolts that, according to technology, cannot be reused. And now the most important thing, as I mentioned, the devastation in the engine is caused by tiny bits of aluminum that get into the cylinders. But where do they come from? Well, the culprit of all this is the EGR cooler. As is known, in all modern diesel engines, part of the exhaust gases emitted by the engine is reintroduced into the engine by the exhaust gas recirculation system. These gases are cooled along the way in a special EGR system cooler. In CFCA engines, it is precisely the defect in this component that leads to their destruction. The exhaust gas coolers were made from material that was too weak and crumbled from the inside. Particles of these cooler fins were pushed through the intake system into the cylinders. This EGR cooler is defective, so it needs to be replaced. The cost of this component must be considered when deciding on the repair or replacement of the engine. New CFC engines are sold with an improved EGR module. If the engine we are overhauling has a cooler with the letter A, B or C at the end of the part number, it must be replaced. Such a new component, already with the defect eliminated, costs over 5,000 zlotys. If the EGR was previously replaced and there is a part installed with a number ending in the letter D, we can leave it. These coolers do not have the previously mentioned defect. Now, we will calculate and inform you about the repair cost. We will help you decide whether it is worth repairing your engine or better to replace it with a new one. The choice of the most beneficial repair method depends on many factors I mentioned earlier.
In our service, we can repair your engine. You can buy a new engine with a 2-year manufacturer's warranty or another refurbished engine. Which solution do you choose? Once you decide to regenerate the engine, skosić, poesać szarpajszymi sztylionami za simulants, we get to work. We have already disassembled, cleaned and checked the cylinder head for leaks.
It is sealed, so it can be regenerated, which will save a few thousand that a new one would cost. In every cylinder head with a CFCA engine, we replace the valve guides because their wear is excessive, which can also contribute to oil consumption. Of course, when refurbishing the cylinder head, we always machine the valve seats. We perform this process using the latest CNC milling machine from Newen, which guarantees the highest precision in finishing the valve seat surface. In every refurbished cylinder head, we plane the surface that contacts the gasket. The valves that have been deemed suitable to keep must be processed using a valve grinder from the American company Quickway. After all these procedures, we can assemble the head, of course, using new valve seals and, in this case, new exhaust valves and reconditioned intake valves. Now, we will check the valve tightness and the head is ready for assembly. We proceed to the engine block regeneration. In this block, the wear is so significant that a second grind of 50 hundredths of a millimeter is necessary, so we will use oversized pistons, which are available for this engine. We are boring the block to fit the size of the new pistons. Now, we are leveling the surface of the block that contacts the head gasket. At the end, of course, we perform the finishing process of the cylinders, which is honing. After completing these tasks, the block will be finally cleaned before assembly. Now, we can start assembling. We install new oil spray nozzles. The crankshaft was checked. It wasn't bent. No surprise. Since it wasn't seized. However, it was worn enough to require the first grind, so it was machined. The crankshaft after grinding, so we use oversized bearings. The company, Kolb & Schmidt, which is a supplier of original parts for Volkswagen, also produces such bearings. All fastening bolts, including those for the main bearings and connecting rods, and many others, are replaced with new ones according to the technology. We install crankshaft sealing collars, of course, always new ones. We install pistons, as I mentioned, oversized, of course of the highest quality, meaning from the company Kolb & Schmidt or Mahler. We have installed the pistons, so now we will measure how much they protrude to select the thickness of the head gasket. This is also the last chance to check if the connecting rods in our engine are not shortened. If any are shorter, they need to be replaced. And now, an interesting fact. Remember this? Yes, this is the famous balance shaft module, whose defect caused the seizing of the first 2.0 TDI engines with unit injectors due to loss of lubrication. It is also present in CFC engines. They improved the socket a bit, it's now deeper, but it still sometimes wears out, causing the oil pump to stop and the engine to seize. Keeping this module would be too much of a risk. Of course, these shafts can be regenerated, but we opt for a better and more reliable solution. We install a new belt-driven oil pump, the kind that is used in 2-liter TDI engines with 140 horsepower. It is reliable and more efficient than the one that was installed here. We are installing the oil pan. With the appropriately thick gasket selected, we can install the head, of course, using new bolts. We are installing hydraulic lifters and valve rockers. We use new elements for every overhauled engine. Now we will install the camshafts. In every CFC engine overhauled here, we replace the camshafts because they are usually worn out to the point that they are not suitable for reinstallation. For every overhauled engine, we use a new valve cover along with a breather. We attach the previously checked injectors and the EGR module exclusively with the number 03L115512D as in Danuta. With the engine assembled like this, we can equip it with accessories and install it back into the car. We show this process in the next video using a new engine as an example, so we won't repeat ourselves, because all the steps related to disassembling and assembling a refurbished engine are identical to those for a new engine. If you liked this video, give it a thumbs up and subscribe to our channel. Also, watch our other videos and of course, take advantage of our services.